Good morning, everyone. I am Simon Anthony Morala from BSN 2A, and today I will be discussing measures of position for ungrouped data, in particular quartile, decile, and percentile. So let's start. First, we need to understand the nomenclature. So nomenclature is the act of assigning names from the Latin root word nomen, which means name. So first, quartile. So quartiles are for equal to 4, hence quartile. Decile from deci, meaning 10, and percentile, meaning percentage. So for quartiles, to understand quartiles, in simple definition, quartiles are the values that are divided into 4 equal parts. And to learn how to get the quartiles of ungrouped data, there are two methods in getting them, which are the Mendenhall and Sinkich method and linear interpolation method. So for this lesson, I will be discussing only Mendenhall and Sinkich method. So what will we get for quartiles? So our Q1 will be our lower quartile, our Q2 will be our median, and our Q3 will be our upper quartile. So first, the rules in using Mendenhall and Sinkich method. For Q1, lower quartile is equal to 0.25n plus 1. Our rule is if lower quartile Q1 falls halfway between two integers, we round up the answer. So for Q3 upper quartile is equal to 0.75n plus 1. So if upper quartile or Q3 falls halfway between two integers, we round down the answer. So this one and this one are the formulas for our lower and upper quartiles. Next, here is an example. So quartiles using Mendenhall and Sinkich method. And here, our n will be the total number of data. So for our first example, what are the quartiles for the following set of numbers? So we have the data that are 8, 11, 20, 10, 2, 17, 15, 5, 16, 15, and 6. So first, we need to arrange all the data in an ascending order. So we have here our 2, 2, 5, 5, 6, 6, 8, 8, 10, 10, and so on. So now that we have arranged our data, let's proceed. So here we have the data that is already in ascending order, and our n here is 11. This is our total number of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hence 11. So for our lower quartile or Q1, we get 0.25 times n plus 1. This is our formula. Then we substitute 0.25 times 11 plus 1. N is 11 plus 1. So 0.25 times 12. Then our Q1 will become 3. So next, our quartile Q2, 0.5 n plus 1. So we substitute again. So n, 11 plus 1. So 0.5 times 12. Our median will become 6. Upper quartile, Q3, 0.75 again, n plus 1. 0.75 n, substitute 11 plus 1. 0.75, 11 plus 1 is 12. So our Q3 will be our 9. So if you're asking, why are these data, some of these data are not here? So we should remember that This 3 doesn't mean the number 3. It means the third in the data. So 1, 2, 3. That is 6. Then for our Q2, 1, 2, 3, 4, 5, 6. It is 11. And our upper quartile Q3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 16. 16 is our quartile. So, good reminder is for our Q1, we only, they all have n plus 1, as we can see. So, for our Q1, we only have to remember 0.25. For our Q2, we need to remember 0.5. And for our Q3, our upper quartile, we remember 0.75. So next, we have our deciles. To understand deciles, deciles are the values that divided into 10 equal parts. So to learn how to get the deciles of ungrouped data, we use the formula dk is equal to k over 10, because decile 10, times n plus 1. So n plus 1 is here again. So in this formula, k stands for the position of the deciles, and n is the same, the total number of data. So let's proceed. So we have an example here. So find D6 among the data given. Our data is 11, 25, 20, 15, 24, 28, 19, and 21. So what will we do first? So we arrange the data in an ascending order. So 11, 15, 19, 20, 21, 24, 25, 28. Now that we have arranged the data, we can proceed to getting the decile. So here I have the formula. So our total number of data is 8. 1, 2, 3, 4, 5, 6, 7, 8. So they are asking for D6. So we substitute. D6 is equal to 6, k, over 10, because decile, times, substitute n, 8 plus 1. So after substituting, we have 6 over 10 times 9, which is equal to 5.4, or rounded off equals to 5. So we also observe here the same rule of rounding up and rounding down from quartiles. Next, we have our percentile. So percentiles are the values that are divided into 100 equal parts. So for here, we use the formula pk over pk is equal to k over 100 percentile times n plus 1, where k is equal to the position of the percentiles and n is again the total number of data. So for our example, so don't mind this. So the following is the monthly income of 8 persons working in a factory. Find P30 income value. So the 30% of income value. Here we have our data 10, 14, 36, 25, 15, 21, 29, and 17. Now, we arrange again the data in an ascending order. So we have 10, 14, 15, 17, 21, 25, 29, and 36. Now that we have arranged, let us proceed. So, our total data again is 8. So 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. They are asking for P30. So, our formula is here. Pk is equal to k over 100 times n plus 1. So, we substitute. So, They're asking for P30. P30, RK is 30 over 100 times N. So our total number of data is 8 plus 1. Next, we proceed is we have 30 over 100 times 9. That is equal to 2.7, or if rounded off is equal to 3. So our P30 is equal to 3. If we want to get the specific value of P30, we have this formula. Second data, which is 1, 2, plus 0.7 times the third data minus the second data. So we substitute. Second data, 1, 2, 14 plus 0.7 times 50, third data, which is 15, 1, 2, 3, and the second data, which is 14. Then we simplify. 14 plus 0.7. Why? Because 0.7 times 1 is 0.7. Then 14 plus 0.7 is equal to 14.7. So P30 is equal to 14.7. Next. Next, we have percentile rank. So percentile rank is the percentile corresponding to a given value x and computed by using the formula. The formula is percentile rank of x, which is our given value, is equal to the number of values below x plus 0.5 over n, total number of data, times 100. So here's our example. A student got a score of 40 on a test. Find the percentile rank of his score on a dataset of 49, 38, 45, 25, 30, 40, and 41. So again, we arrange the data in an ascending order. So 25, 30, 38, 40, 41, 45, and 49. Now that we have arranged, we proceed. So in this problem, our n is equal to 7. So we are finding the percentile rank of 40. So we use this formula and substitute. So percentile rank of x. So x they are finding is 40, which is here. We use I use PR to represent percentile rank. So x is equal to 40 plus the number of values below 40. So here is 40. 1, 2, 3. So there are 3 values. 3 values. Here is 3 plus 0.5. Here, 0.5 over 7, because our total number of data is 7 times 100. So 3 plus 0.5 is equal to 3.5 over 7 times 100, which will result in 0.5 times 100. So our PR 40, or percentile rank of 40, is equal to 50%. So that is all for today's discussion. I hope you have understand, and see you next time.